This video is about B3, uniform accelerated motion in one direction. In this video, we'll be making use of 5 equations for uniform acceleration. These are derived in a different video if you want to watch that. This sheet relies on you finding the correct equation to use, rearranging, substituting and getting the answer. But there are a couple of tricks in it. For example, if the question refers to a body being dropped, we have to assume that the acceleration is the acceleration due to gravity, which is given as 9.8 meters per second squared. The second trick is that if your body is being dropped, then its initial speed is 0, and the question won't necessarily make that obvious. Conversely, if an object is thrown directly vertical upwards, then it's going to stop when it reaches the maximum height, and so the final velocity in that situation would be 0. And it is very common for questions not to tell you these little bits of information which you deduce by reading the context of the question. So let's have a look at a couple of questions as examples. Let us suppose you have an object dropped from 10 meters and we want to know how long it will take to reach the ground. Well, what information do we know in this situation? We know the acceleration. The acceleration will be equal to 9.8 meters per second squared. We know the initial velocity. The initial velocity is 0 meters per second. We don't know the final velocity, but we also don't care about the final velocity. We know the displacement, that's 10 meters. And what we're asked to find is the time. And so we have to use the equation of motion that does not have a v in it. Now you'll notice this question has a nasty quadratic in it, but fortunately because u is 0, then the quadratic becomes much easier to solve. This isn't always the case. So with u equals 0, the equation becomes s equals half at squared. We want to calculate t, so we make t the subject. And we're going to take the positive root, although due to symmetry it won't really matter. And you can see the object would take approximately 1.4 seconds to hit the ground. If we were asked, well, how far up would you have to drop the object for it to take 1 second to hit the ground, you would use the same equation, but you would substitute t as 1, a as 9.8, u is still 0 because we're still dropping the object, and use that to compute s, the displacement. But it would be the same equation. Let's imagine a different question now. A car is travelling at 15 meters per second and the brakes are applied 10 meters away from a wall. And we want to know what the minimum acceleration is that will stop the car before it hits the wall. And we're asked what that acceleration is. So we'll do the same approach as last time. We'll make a list of our variables. The acceleration is what we want to calculate. We know the initial velocity is 1.5 meters per second. We know the displacement is going to be 10 meters. The final velocity, although it isn't given to us, it is in the context of the question. We want the object to stop, so that will be 0 meters per second. And the time is irrelevant to this question. So we are looking for the no t equation, and the no t equation is this one. So we take this equation, we rearrange it to make the acceleration the subject, we substitute our numbers in, and we have to be very careful of our sign, because if we defined our initial velocity as being positive when moving to the right, then our acceleration will be negative, and that's what the maths will show. So it's the same approach to solve this problem as before, but we ended up using a different equation. Any of these questions for uniform accelerated motion, you use these 5 equations. You write down what you know, you find which value you don't know and you don't need to know, and that'll tell you which of these 5 equations to use. Then you rearrange the equation to make the unknown the subject, substitute your numbers and solve.